0. So we get sum of 1 carry out of 0. Now the bonus is a little bit tricky. So indicating the times when the outputs would be stable. So we know that each of these numbers has to be smaller than 40, 35, 60, 55, 95, and 90. So each of these are going to be smaller than that because they're going to be less than or equal to, I guess is more accurate to say. Basically, we're going to have to treat it so they've been zeros for a very long time, and we're changing this. So 0, 0, 1. So we know that the sum bit's going to change, but this is actually stable because we haven't actually changed anything. So let me just double check. This should stay stable unless we have a static 0 hazard. So 0, we have Cin is going to go here and going to go here. So some bit's going to change at 20 nanoseconds. And these are going to, this is going to stay 0, 0, and this is going to output 0, 0 the entire time. So this is available at 0 nanoseconds, and this is available at 20. So now, taking that information into account, this comes in at 20, and then this is available at 0 and 0. So Cin comes in at 20, and how long does it take for S2 and C2 to change? So we have a 1 and a 1 here, so that's going to become a 1 after 10 nanoseconds, and that's going to become a 1 at 5 plus 5. So this is going to be available at 15 nanoseconds. And it's going to keep staying a 1 because that 1 is staying there. So regardless of what happens with the rest of this, that Cs not changing after 15. And now, after that, we've got to find S2, which is available at 20 nanoseconds. 20 plus 20. Let's see if that comes out. Let's figure out. So at 20 nanoseconds, this is receiving a 0 here. And we basically need to wait for this to become a 1. Wait. No, sorry. What is that putting? So S1 is 1. So Cn is 1 at time 20. And then A is going to be is going to be 1 at time 0, and B will be 1 at time 0. So we can get rid of those now. And so at times this will be 1 at time 10, and so this will be 1 at time 15, mentioned earlier. So this is going to be 0. This is going to stay 0 the entire time. And this is going to be 20 at time. So this is 1. So this is 0. XOR 1 is 1. So this will be available at time 40. And now we need to do this for this one as well. So this is C1. So C1 is 0. So that was available at time 0. So I'm going to redo this yet one more time. A lot of scratch outs on this one. So it's going to be 0 at time 0. We know that because the C1 was stable at time 0. And then we have this coming in. So the C out was available. C2 was available at 15 nanoseconds. And that is our B. So this was a 1 at time 15, and A was a 1 at time 0. So we need to figure out S3. So these both went from 0. So this changed from a 0 to a 1 faster than this one. Do you see how that happens? So this was going to change to this XOR would change. So this was 0 at time 0. And so initially we have at time 0, or time 10, this is 0 ANDed with 1, so that's 0. And then we have 1 ANDed with 0, so this is going to be 1 at time 0. And then we have 0 ANDed with 0, 0, 1, so this is going to stay 0 at time 10. And this was originally 0 at time 0. And then 0 at, or 0 is staying 0, so this is actually also available at time 0. No, sorry, I made a mistake. Sorry. This is 1, 1. So yes, initially this is at 0. But then this changes at 15, sorry. So that's going to change this from 1, 0 to 1, 1. So this is going to change to 0 again. At what time? 15 plus 20, so at 35. This goes back down to 0. That's not going to change that, so that's okay. And then this changes at time 15 plus 10, so at 25, this becomes a 1. So at 25 plus 5, this becomes, so at time 30, this becomes a 1. So that's available at 30. And then S3 is available at what time? So this is available at time 0. And basically, so this goes, like as we see here, it goes up from 0 to basically from time 20 until time 35, when this drops back down to 0. So 35 plus 20, so that's available, stable at 55. And that is the full problem for solution for problem 5.